Good. Are you satisfied? The definition of a domain and the examples that I've given? Those who are having problems with the domain?
No.
Not, can we have example as the one in the assignment?
The one in the assignment. I don't want to talk about the one in the assignment because some of you are not added in, but I can give a similar. It actually looks like this.
Okay, give us similar one.
The function in the assignment looks like this. It was also a rational expression. The numerator and the denominator were also, they were polynomials.
They were polynomials, but we did not know the values of they did not have numbers.
They did not have numbers. Oh, okay, okay. Now I get the idea. So, well, it's no problem. We can still talk about it. The function was it 2y plus 1 divided by y minus
Theta.
y minus theta. Is this the function I gave?
It's y minus 0.
No. This was y minus theta. This is a Greek. This is a Greek. The Greek letter. It's pronounced as theta. This was not 0. It's theta.
Yeah.
I remember in the instructions I told you that all the letters X, Y, A, B, C, theta, tau, gamma, they represent real numbers. So this was theta. How do you find the domain of this function? This is a rational expression. And you know there will be a problem when the denominator is 0. So straight away, you want to avoid the situation where y minus theta is 0. This will happen at the point y is equal to theta. So what will be a domain? The domain of this function will be all the real numbers except the number theta, where theta is a variable. It could be anything. I could let theta be 1, I could let it be 5, I could let it be 2 billion, I could let it be 2 trillions, doesn't matter. But as long as the value of y is theta, this function is not well defined. So our domain is all the real numbers which as long as we exclude the point theta. Or you could just write this as y in R such that y is never. Okay.
I have a question.
Uh-huh.
Okay, so for me, for this question, I substituted theta for a number and I said, let theta be, let's say, for example, 2. Is that okay?
Why did you do that?
I don't know. I just thought to do it.
Same, I did the same.
I mean, you kind of said all those theta
Are real
gamma
numbers.
are real numbers. So
you took a particular case.
Yes, and I explained what case I took.
Okay, I will see. I have not looked at your assignment. After this, I will start to grade. I will see what to do. But I don't want to comment on it about it now.
So I have a question.
Then there was also another question. You are to find the value of this function at the point y is gamma, right? So that means you are to compute f of gamma. Just substitute y with gamma. So here you will have 2 gamma plus 1 divided by gamma minus theta. And of course, we know the domain. So this gamma must never be equal to theta. You must restrict your domain. This is only
Was that gamma or y?
That was gamma. And gamma, it's not.
Y was equal
It
to
looked
gamma.
like a
I thought
y.
it was R.
That was
all
gamma.
those signs were very confusing. I thought that theta was 0. Like it was really confusing. But anyways.
0, 1.
Really, but I typed this. I typed this in LaTeX, so it should have.
Yeah, it was at the side. It was clear.
Because I typed it in LaTeX, so it should be very clear. This should have been very clear. Type it in LaTeX.
Okay, sorry, sir. I have a question. Oh, for the domain part before we go to the second part. So the writings R minus theta is it still okay if you write it like R minus the singleton theta, which means you put theta on his own bracket as well? Is it still okay to do that?
Yeah, it's okay. There's no problem.
Okay, so for the second part of the question, I don't know if it was only me, but me, I was really confused when you said the second part, what is its value? I was confused. It was representing the expression or
Yes.
the domain.
It was
And
the function.
that was not clear. If maybe next time you can make it more clear.
Well, I didn't want to use, have we discussed range before? Have we talked
No.
about range of a function? Yeah, that's why I was avoiding to use that term.
But just please next time make it clear, because I was personally really confused.
You should have sent me an email about that. But
It was in the evening, but I asked a couple of people. I think I got the same answer.
It's okay. I will look into that next time. Huh?
I have a question.
Uh-huh.
So when you're doing the domain, must you put the function?
What do you mean must you put the function?
Like y is equals to real number, comma, theta. Just like that.
I don't understand. What do you mean? You mean y is equal to?
Bracket,
Bracket?
real number.
Which bracket? Curly braces, square bracket, parentheses. You mean this or for set?
Yeah, for the any function is a meifanya sai.
What exactly do you want to do with these brackets? I don't understand your.
I mean that must you put the any function?
Must you put the function where?
Like if you don't want to write the domain is a set of all real numbers apart from theta. The other way of writing it's like x that contains j something.
You want, so for example, you want to say x such that x is not equal to maybe 6. You want to say something like that?
Yeah.
Yeah, you can do that, but you must tell me that this x is a real number. You must tell us what x is. You don't just go about writing x, y, z without. That's why at the instruction page, I put it clear that for this quiz, the letters x, y, a, b, c, d, blah, blah, blah represent real numbers. You must always define the symbols that you use. Mathematics is like a language. So someone reading this must be able to understand which language you are speaking. Okay? That's why it's always advisable to define the symbols and the variables that you use. But
So, sir,
now you can do this.
what is the final answer?
Final answer, what?
For that exercise you just did, the final answer was?
So that exercise, that question had two parts. The first part was the domain.
Yeah.
The domain is when the denominator is non-zero. So you can take the real line and exclude the point theta. That gives you the domain. And then the value of the function at gamma, so the function was 2y plus 1 divided by y minus theta. Just substitute, y is a variable. So the value of this function will be 2 gamma plus 1 divided by gamma minus theta. That will be the value of the expression at the point y is gamma. Okay.
So, sir.
Sure, could you bring the board closer?
That should be fine now. It should be fine. Huh? Is it fine now?
Yeah.
Yes, sir.
Okay, please, we will have time to discuss the assignment. Let us not discuss the assignment for this class. We need to, I think we need to proceed with today's discussion. We will have time to discuss the assignment next week before your midterm. Okay? So last time we were looking at linear equations in one variable, and we discussed some rules, essentially 2 rules, which will help us to solve linear equations that add the same term to both sides of the equation. Well, you get an equivalent system. So the solution to the new system is the same as the solution to the original system that you started with. And of course, that means also subtraction works the same. So for instance, you're adding a negative constant, then it means subtracting the same constant from both sides of the same, from both terms of the equation, which are on different sides, will also give you an equivalent system. And then also that when you scale both sides by a non-zero term, you get an equivalent system. So this term which you're using to scale does not necessarily have an integer or a whole number. It can also be a fraction. So it means if you divide both sides by a non-zero term, then you also get an equivalent system. So we also talked about rational functions. How do you solve linear equations for which the unknown variable is expressed as fractions? I gave you the definition of a linear equation, and we also gave some examples of equations which are not linear and the reasons for which they are not linear. Now today, I want us to proceed with the discussion on rational expressions or rational equations. Rational equations. So, and the last statement I made was that alpha divided by n plus 1 divided by x minus n is x plus 1 divided by x minus n. In general, for any real number alpha.
I really cannot see the board. I don't know if it's just me.
Yeah, we can see the board.
Yeah, it's become blurry.
Very blurry.
Is it still blurry?
Yeah.
Yeah.
So is there a way to get more light in? Because I think the camera is struggling to focus.
Okay. How about now? How about now?
No, nothing has changed.
Nothing has changed.
I can't see anything on the board.
You have a better pen.
Your marker is
I've switched on all the lights. It should be fine now.
So could you try moving the
Not
camera?
really. Or try using the darker pen.
Just try to move this closer. If I write that, are you able to see what I've written?
Yes.
Okay. Let's hope this is going to work. So last time we were discussing rational expressions, and I told you that in general, this kind of equation will not have solutions. This is an example of a linear equation or a rational equation which does not have solutions, because you will find solutions for which the denominators are zeros. Okay, and we do not accept division by zero in mathematics. Now, so this calls for restriction of the domain of the function. And I think this is the right setup to discuss this. So for example, if someone gives you an equation like x plus 1 divided by x plus 3 plus 1 divided by maybe x squared plus 2x minus 3 is equal to 1. It has to solve for x. Solve for x. Then we have just discussed the domain of a function. You know that this kind of function or this expression will not make sense when x plus 3 is 0, at the same time when x squared plus 2x minus 3 is 0. Because when the denominators are 0, this expression does not make any mathematical sense. It doesn't have any mathematical meaning. So we will restrict the domain of this function to exclude the points which are the zeros of the domain, okay? The zeros of the denominators, sorry. So first and foremost, you know, this expression should not, we do not permit the values x is -3. And you can also factor this, look for two numbers whose product is -3 and sum is 2. So if I take 3 and -1, therefore this expression will be x plus 3 times x minus 1. That is how it will factor. Then by the property of real numbers, if you have any two factors of real numbers whose product is 0, then one of them must be 0. So this means either x plus 3 is 0 or x minus 1 is 0, from which you get that x is -3 or x is equal to 1. So the whole of this expression is defined, so the domain will be x such that x is not equal to 3 and the same
Excuse me, we
x
can see there.
equal to 1.
We can see.
So we can't see what you've written down there.
No. We can still see.
You've taken it up.
Yeah, should be good now.
Just a bit.
Should be good now. So I was just showing you how to restrict the domain, or in other words, to find the domain of this function. So you know that this will not be defined at the points -3 and +1. And then to solve this kind of expression, we will proceed as we did last time with expressions involving fractions. And the first step is, if you're able to factor this, then you can write this expression as x plus 1 divided by x plus 3 plus 1 divided by, we want to factorize this, which we already done here. So I just replace x plus 3 to x minus 1, this should be equal to 1. Then the next step is to look for the LCM of the denominators. In this case, x plus 3 minus 1 times x minus 1, and then 1. The LCM in this case happens to be x plus 3 times x minus 1. Then multiply each term by the LCM. And the LCM of the denominators, multiply each term by the LCM. So we take x plus 1 divided by x plus 3, all this times x plus 3 times x minus 1 plus 1 divided by x plus 3 times x minus 1, this times x plus 3 times x minus 1 is equal to, so multiply this by LCM, you get x plus 3 times x minus 1. Then I have similar terms, x plus 3 and x plus 3. So these two guys cancel. I remain with x plus 1 times x minus 1 from the first term. The second term, all these terms cancel. We remain with 1, must be equal to. And then on the right hand side, we simply have x plus 3 times x minus 1. Now we can go ahead and expand these two expressions, but I don't want to do that. I want to make our work easier. You notice that x minus 1, there's an x minus 1 this side, and there's an x minus 1 on the other side. Okay. What you can do is to subtract the left hand side, right hand side time from both sides, and also subtract 1 from both sides. So I want to perform two operations at a go. We will have x plus 1 times x minus 1. We subtract x plus 3 times x minus 1. Of course, if I subtract it from this other side, we get a 0, must be equal to -1. So where -1 is, if I subtract 1 from this side, I get a 0 on this other side, so I get a -1. Then now we can do factorization. These are common factors, x minus 1. Okay, so pull out x minus 1. In the first term, you get x plus 1 minus the second term, you get in bracket x plus 3 is equal to -1. Then work out what is inside this parenthesis. So outside we have x minus 1. Inside we have x plus 1. We want to open this inside parenthesis. So minus x minus 3 is equal to -1. So what does this give you? Of course, here there will be an x minus x, which is 0, then 1 minus 3, which is -2. So inside this big bracket, we have a -2. So we will have x minus 1 multiplied by 2 is equal to -1. Okay, you can open this bracket, parenthesis, so -2 times x, that is -2x, -2 times -1, that is +2. This gives you -1. Therefore, -2x is -1 minus 2, which is -3. Okay, subtract 2 from both sides. And therefore, x must be 3/2. So this expression is satisfied at the point x is 3/2. Of course, assuming that our calculations are right, we do not miss any step. So in general, when you find rational equations like this, if in case one of the denominators is not linear, factor it. Factor that denominator and then find the LCM. Then after finding the LCM, use the LCM to multiply each of the terms. Like we have done here, multiply each term by the LCM to do away with the fractions. That is essentially the reason for multiplying with the LCM. And then after that, proceed in the usual way. You can do factorization if it's possible. You can do distribution if it's possible, because these are real numbers. So the distributive property will help you, and then the usual way of solving linear equations.
Excuse me, sir. Could you?
Can you repeat from the LCM part?
From here,
Yeah.
did you understand how we got the LCM?
How is the LCM x plus 3 and x minus 1 when there's also another x plus 3?
X plus 3 times x is this product.
Yeah.
This is how you get the LCM. We have done this in a previous class, I think. Just like the way you do with the numbers. So for example, if you have, let's say 3 numbers, let's say 2, 4, and I don't know, maybe 7. How do you find the LCM? You start with the smallest prime number, which is 2. 2 divides 2 once, divides 4 twice, it does not divide 7. And then 2 cannot divide 1, but divides 2. And then the next prime number is 3, cannot divide any of these guys. 5 cannot divide any of these guys, so we pick 7 as the next prime. 7 divides 7.
I'm asking about now the equation.
Now for the LCM in this case is 2 times 2 times 7, which is 28. We do the same for these expressions. So we are looking for LCM of x plus 3, then x plus 3 times x minus 1 and 1. The procedure of finding the LCM is the same. Start with the smallest common factor, for example, x minus 1. X minus 1 does not divide x plus 3, okay? But x minus 1 divides this middle term, and you get x plus 3. And then, of course, cannot divide 1. Then the next factor is x plus 3, which divides the first term once and divides this term. So we have done the division until for each and every term we have a 1 at the end, so there's no remainder. Therefore, the LCM is this product, x minus 1 times x plus 3. That is how we got this LCM. Is that okay? Is it okay? Does everyone understand how we get the LCM?
We understand.
Could you change the clothes and
Trevor, mute your mic.
Who is that talking? Hello? Does this argument make sense to you? How to find the LCM?
Yes.
Okay.
Yes.
So after finding the LCM, the next step, which we did, is to multiply each and every term by this LCM. So take the first term, multiply by the LCM. Take the second term, multiply by the LCM. Take the third term, multiply by the LCM. That's exactly what I did. So I took x plus 1 divided by x plus 3. All this I multiplied by x plus 3 times x minus 1. Plus the middle term is 1 divided by x plus 3 times x minus 1. I multiplied this by x plus 3 times x minus 1. This is equal to 1 times the LCM, which is x plus 3 times x minus 1. And now just identify common factors. So for example, x plus 3 and x plus 3, they divide each other, so that in the first term you just have x plus 1 times x minus 1 plus x plus 3 divides itself, x minus 1 divides itself. So in the middle term, we just have 1 is equal to, and then on the right hand side, we just have x plus 3 times x minus 1. Then at this stage, you can make use of the fact that x plus 1, that x minus 1 is a common factor, or you can just go ahead and expand these expressions. You should get the same answer. So for example, this time around, if I decide to expand, this is a difference of squares. There's x plus 1 and x minus 1. So this term, if you expand, you should get x squared minus 1. That is this term. And then plus 1 should be equal to, you can now expand this guy, but we know this was the factorization for this guy. So this is x squared plus 2x minus 3. Okay. Of course, minus 1 plus 1 is 0. So on the left hand side, we have x squared is equal to x squared plus 2x minus 3. Subtract x squared from both sides because it's common. So on the right hand side, we have 0. I mean, on the left hand side. And then the other side, we have 2x minus 3. Add 3 to both sides. So you will have 3 is 2x. This means x should be 3/2, which is the same answer that we got. Except that the first time I made use of the fact that one of the terms is common, and then I could subtract and make use of the distributive property. And you still arrive at the same answer. So the key concept here is being able to find the LCM for the rational expression, and then multiplying each term by the LCM. Of course, once you're able to identify common factors, that will help you because some terms will collapse. If you have any common terms, you can always divide and get a simpler expression. You can either expand as we have done here, or you could make use of the common factors so that you make sure they're on the same side, and then you use the distributive property to factor out and simplify your work. Is that okay? The only skill you need to remember here is how to find the LCM of the denominator, and then how to multiply each of the terms by the LCM. Past this stage, you have a linear equation which you can solve by the techniques which you have learned before. Fair enough? No one is talking.
Yes, sir.
No one is talking. Are you guys still there?
We are here.
Okay.
Yes, we are.
Yes, we are.
Okay, so now I want to discuss some few applications of linear equations. Now that we know what are linear equations, at least you can define a linear equation, you can give examples, you can solve a linear equation, you can solve a rational equation. Where do we use them? Does it even make sense to learn this kind of mathematics? Where is it used? So linear equations are applied in so many areas of science. Let's discuss applications. Applications of linear equations. There's a time I made a statement that all the laws of the universe are governed by equations. So these equations or formulas, you can use them to describe physical processes like motion, processes like, for example, in a factory or in general in the production process, you want to estimate the cost of producing an item. It's normally given as a function, and in some cases you can get a linear function. So the knowledge of being able to solve linear equations can help in such cases where you have processes which can be represented by linear functions. For example, the profit, how to get profit, is the difference of it's the difference between the cost of production and what you get after selling the product, which is a linear function. So in case I have the cost of production and I have the income that I get from selling this item, then I know that the profit is just the difference. But there are other areas where you can apply linear equations. I will give you examples. Let me think of a problem which you can apply in equation. Suppose there is a student who has scored maybe 70, 30, and 50 in the first 3 exams. In the first 3 exams. This student has a target of scoring an average of 60 in the entire exam, because the overall score is obtained by getting the averages. So the question is, what score must be attained in the 4th exam? To guarantee maybe an average of 55%. So you have a problem. There is an unknown variable. The unknown variable in this case is the score in the 4th exam. Okay, how do you approach this? So let the score be, let's say, X. So let the score in the 4th exam be X. So in total, the student scores 70 plus 30 plus 50 plus X. How do you get average or mean? It's simply the sum of all the items divided by the total number of the items. So in this case, we have added 1, 2, 3, 4 terms. This should give us the average. We are aiming to achieve an average of 55. So take this and equate to 55. And quickly realize that this is a linear equation, because the known variable here is X has degree 1.
Shouldn't it be 55 of 100?
This is a linear equation. Sorry?
Shouldn't it be 55 over 100 because it's percentage?
Yes, even these ones are percentage. Even these ones are percentage. So it's okay there. The 100 is taken care of because for everybody it's out of 100. So then you know how to solve such kind of an expression. Huh? Multiply both sides by 4. Okay. And then add this term. So this is 70 plus 80. So you get 150 plus X must be equal to 220, where 220 is obtained by multiplying 55 by 4. This side, if I multiply by 4, 4 cancels, so I just get 1. And then 150 is 70 plus 30 plus 50. X is still there. So to get X here, you subtract 150 from both sides. So X must be 220 minus 150. And that is, I think, 70. So in this case, this particular student must score a 70 in the final exam to guarantee an average of 55. Okay.
Sir, will you give us such problems to solve?
Yes, you will get such problems.
Okay.
Where you will have to assign some unknown, any variable of your choice, and then, work out the problem. So after assigning the known variable, you get a linear equation from the problem, and then you solve that linear equation and get the value of the unknown. We could also apply linear equations in finance. Okay. Let me think of a problem in finance. Suppose you invest
We can see.
$10,000. And you want part of it at 9% interest rate.
Excuse me, sir. We can't really see what you've written. It's a bit blurry.
How about so the middle?
The middle is okay.
The middle is okay.
Yeah.
I guess it should be okay now. Are you able to see the board? Are you able to see this writing?
Yes. Yes.
Okay, so we are thinking of a problem in finance where you could apply linear equations. So suppose you want to invest $10,000. You want part of it to be at 9% interest rate. And the rest at 14% interest rate. Okay, then assume that total interest to be earned is 1,000, maybe $245 of course. How should the money be invested? Is the question. How should the money be invested? In other words, which part of this should we invest at 9% and which part should we invest at 14%? So that at the end of the day, you earn $12.45 as your interest. Okay. Any idea? Can I get suggestions from you on how to approach this kind of problem? Of course, this 9% means 9% of what is invested. So if you invest, let's say 10,000, the interest is 9% of 10,000. Okay, and if you invest here, let's say 5,000, the interest is 14% of 5,000. This is just simple interest rate. Any idea on how to approach a problem like this? Any suggestions? Hello? I want to see what you guys are thinking. Can someone tell me what to do?
Sir,
Yes.
could it be X divided by 10,000 times the first interest rate plus X divided by 10,000 times 14? The next interest rate is equals to 1,245.
Why will you do that?
I have another suggestion.
Like what is x? What is x in this case?
Oh, sorry. Maybe the second one should be y. X and then y.
We just want one variable. This is a linear. We need a linear equation. So just one variable in one variable. Of
I
course,
have a suggestion.
the person who is talking about x and y, I can give you an idea that x plus y is 10,000. With this, are you able to add something to your idea? There's a new suggestion. Go ahead. Please go ahead.
Maybe we can have x and 10,000 minus x.
Yes, that is what I was hinting at by writing this. So from this, if you subtract x from both sides, y is 10,000 minus x. So now when I take x and 10,000 minus x, there's only one unknown, okay? So perhaps for those who are wondering what is x and what is y and why are we doing this, the whole sum is 10,000. We want to invest this, want to split this money into two and invest part of it at 9% and part of it at 14%. So for example, let x be the amount invested at 14%. Okay. You could also choose 9%. There's no problem, you'll arrive at the same answer. So if x of this 10,000 is invested as 14%, then 10,000 minus x will be invested at 9%. And I explained the meaning of this. This is just simple interest rate, where to get the interest, take the percentage of if the interest is 14%, take 14% of what is invested. Then now with this, together with this information of the total interest is that, you can go ahead and find the value of x. So x is invested at 14%. That means the interest earned will be x times 14 divided by 100 plus 10,000 minus x is invested at 9%. So the interest earned will be 9 divided by 100 times 10,000 minus x. Well, these two interests must add up to 1245. And boom, we have a linear equation with x, which is pretty easy to solve. Okay, so this is just 0.14x plus, let's see, plus 900 minus 0.09x is 1245. Okay, then just collect like terms. So you have 0.14x minus 0.09x is equal to,
Yes, you can see below there.
5. Let me write. Let me write this side. So we have 0.14x minus 0.09x is 1245 minus 900. So 1245 minus 900. What is 0.14 minus 0.09? 0.05 x plus equal to 1245 minus 900.
345.
345. 45. Therefore, to get x, divide both sides by 0.05, so that should be 345 divided by 0.05. What would that give you? So this should be 900. I think so.
Yes.
That is the x. And then of course 10,000 minus x now would be, is it 21? 2100? 21 or 31?
We can see.
3100. So this means to get a $12.45 interest, we need to invest 6,900 at 14% and invest 3,100 at 10%. And we arrived at that conclusion by solving a linear equation problem. Questions before we look at another application? So if you decided to use two variables, then x will be 6,900, y will be 3,100, so that x plus y is 10,000. No questions. Okay. The other application you will find is formulas. So suppose there is a formula that takes in maybe 3 values, it gives an output, and you are aware of 2 of the values, okay? Then you want to find the 3rd value. This happens quite a lot in real life. Let me give you an example in physics. In physics, when you're dealing with the images, there is this 1 over f is 1 over u plus 1 over v. Solve for u. So this equation, f is the focal length of a mirror, u is the image of the object from the mirror, and then v is the image of the object on the other side of the mirror, the distance. So these are actually distances. This is a formula that connects the focal length to the object distance and object distances from the mirror line. So you could have, let's say this is your mirror line, this is the object, and this is the image, these are the distances you're considering, and then the focal length, this is a property of the mirror. Each it's a focal length of the lens that the mirror is made of. So this is a property. You will always get this from the mirror. In some cases it's 2.5, 3.6, or whatever. Suppose I have, for a particular problem, I have a focal length of the mirror and I can measure the image distance, but for some reasons I cannot measure the object distance. Then I can use this relation with the focal length which is given from the mirror and the object distance which I can measure. I don't have to measure the image distance. How do you solve for u? So in this case, you have a linear equation in u. In this case, you get linear equation in u. Because f and v are known to you. So you want to obtain an expression of the form u is equal to something, which is that something that we're looking for. To solve this is very simple. First of all, make sure that 1 over u is by itself. So I could subtract 1 over v from both sides. So there is 1 over f minus 1 over v is 1 over u. Okay. Then I have 1 over u, but I'm not interested in 1 over u. I want u. So that means I should take the reciprocal of this guy. But for me to do that, I must first of all combine this left-hand side. So the LCM of f and v, LCM of this guy is fv.
You can see there.
You can't see from here. Let me write this other side. So we have 1 over f minus 1 over v is 1 over u. And I've said we need to combine this left-hand side. The LCM of f and v is fv. So f divides fv, v times, minus v divides fv, f times, this is equal to 1 divided by u. And this is 1 over u. So how do you get u? Take the reciprocal of the inverse. So if you take the inverse here, it means fv divided by v minus f is u. So you have your u is, so this question mark will be fv divided by v minus f. This will tell you that to obtain the object distance, find the product of the focal length and the image distance divided by the difference of the object of the image distance and the focal length of the mirror. And you will meet this kind of problems in so many instances. For example, for compound interest. So I don't want to. We have looked at simple interest, but you could also meet a similar problem for compound interest, which we will see later on in the course, which is P plus P and T, and you could write this as P into 1 plus RT. Then this is the amount of money you earn at the end of investing an amount P, which is the principal. So suppose someone gives you a principal amount of money and the rate of interest and the time for which they want to invest the money, then you want to calculate by the end of the investment, how much amount of money would they have in the account? Or suppose someone gives you the amount of money that they have earned over a period of time. So the principal plus all the interest, and you also have the principal, and you want to find the interest rate. At what rate was this money invested? Then in that case, you have to make R the subject of the formula from this case, okay? So that from that, A is P into 1 plus RT, we are interested in making R the subject. So first thing, divide both sides by P. Therefore, A divided by P becomes 1 plus RT. Then we want to make sure this term is by itself. So subtract 1 from both sides. So A divided by P minus 1 is RT. Therefore, to find the interest rate, divide both sides by T. So that T is just, R is just 1 over T into A divided by P minus 1. And you can combine this into a single fraction if you like, but you're fine the way it is. You will meet such kind of problems in so many instances where you are expected to manipulate some formula and make one of the variables a subject. There are only two properties which you must master. This is that adding or subtracting the similar term on both sides of an equation does not change the meaning of the equation. It just gives you a similar, an equivalent system, which means a system which will have the same solution as the system which you had before. It also that if you scale both sides of the equation by a non-zero real number, then you do not change the meaning of the equation. Rather, you get an equivalent system, a system whose solution set is the same solution set for the initial problem that you started with. Maybe let's look at an application in geometry. An application in geometry. Okay. Can think of an equation. Suppose you want to fence a swimming pool. Okay. The swimming pool is of length 16 meters, width 15 meters. In addition to this, you want a uniform width around the pool. Let's say you are given, 200 meters of barbed wire. What the length of the uniform width? So this is a problem in geometry, which requires you to apply your knowledge of solving linear equations. And such problems, such geometrical problems, it's advisable to draw a diagram. So let's say you draw a diagram.
So what did you write? Suppose that you want to what?
You want to fence.
Fence, okay.
You want to fence a swimming pool of length 16 meters and width 15 meters. In addition, you want a uniform width around the pool. Given that 200 meters of barbed wire is to be used, what will be the length of this uniform width? So this is our pool, which is 16 by 15. We want a uniform width around. So the shaded area is your pool. And around the pool, you want some uniform length. Okay. Some uniform width. Let's say the length is J. Okay. This length is J. It's J all round. So this is where we're fixing the fence. So from the pool, you move away J meters or so, and then you fix your fence. We are asked that, given that we're supposed to use 200 meters of the barbed wire, whatever kind of fence you want to use, fencing wire, what will be this length of the uniform width? Ideas? I've started you off by drawing the pool and making sure there's a uniform width. So now how do we find J? How do you find J? We know it's going to be a linear equation problem because the only unknown here is j, and it is of degree 1, so it's going to be a linear equation problem. Any ideas? Any ideas? No ideas. So this is where the function is supposed to be. The function is supposed to lie on this. You've been told that this, you're supposed to use 200 meters. Perimeter, have you ever heard of the term perimeter?
So let me try.
Yes, go ahead.
For the length of the border, it will be 2j plus 16.
The border. Ah, okay, I get what you mean. So you want this to be 2j plus 16.
Yeah, 2j plus 16.
And then this other one should be 2j
plus 15.
Plus 15. Yeah, that's right. Now, what do you do with this?
Then now
what kind of shape is this? What kind of geometric shape is this?
Rectangle. It's a rectangle.
It's a rectangle. And what is this 200?
The perimeter.
The perimeter.
So how do you find the perimeter?
2 times the length, 2 times the width.
Perimeter 2. Okay. So we require that 200 must be twice the length. So the length is, so this should be 2 into 2j plus 16 plus 2 into 2j plus 15. This is a linear equation in j. I will go ahead and solve for j. We make use of the distributive property. So we have that 200 is equal to 2 times 2, that is 4. So we have 4j plus 32.
32.
Plus, this is
4j plus 30.
30. Collect like terms. So there's 200 is 8j plus 62. Okay. Therefore, 200 minus 62 must be 8j. So that means j is going to be 138 divided by 8. What will this be? Divide, so this will be 1.25. What do we have here? 558, so that should be 6, that should be 7. 17 point?
17.25.
Yeah, so let's put maybe 17, yeah, 17.25 meters. Okay. So here you should have recalled that you're dealing with a rectangle and you're expected to use this formula for finding the perimeter, the distance all around the rectangle. Any questions?
I have a question.
Yes, speak louder, please.
Okay, so I'm wondering, okay, I understand where the 2j is coming from because you have both 2 sides of the length and 2 sides of the width. But what I don't understand is where are we getting the 2 outside the brackets?
This one.
Yes, the 2 outside the brackets.
You see this formula for perimeter?
Oh, okay, okay.
Yeah, so the 2's come from here. Happy?
Yes, yes.
Any more questions before we look at another one? There are so many, we can't cover all of them. I just selected a few to discuss. No questions, so I guess our next application is on shared work. Try to give a simple example. Suppose John what kind of work do we want? Suppose John can build a house in 7 days. And Joseph is faster, can do the same job. The same job in 4 days. So you have John who can build some house in 7 days, and Joseph can do the same job in 4 days. Is it possible to complete the work in 2 days if both are hired? So we have John who can do this kind of work in 7 days, and then Joseph can do it in 4 days. The question we would like to address is, suppose we combine the effort, we hire both John and Joseph to work at the same time. Can their combined effort, produce the same building or house of the same quality in 2 days? Of course, this is a yes or no question, but for you to say whether it is to say yes or no, you must do some calculation. And this boils down to a linear equation problem. Okay. Have you ever met such kind of problems before?
No.
Not yet. Okay, so I will give you the solution. We need to look at the rate of work. The rate of work in this case is simply the amount of work divided by the time period over which that work is accomplished. So John, we know John can complete the piece of work in 7 days. So in 1 day, John will do a 7. Okay. He can complete the whole task in 7 days. So in 1 single day, he will be able to do a 7. The rate of work for Joseph will be a quarter because he can complete the same job in 4 days. So this will be a quarter. So in this case, I'm taking 1 as the whole amount of work to be done. So if the whole amount of work can be done in 7 days, then in 1 day, this guy is doing just a 7. And the guy who is doing 4 can only do a quarter in 1 day, okay? But now we are combining this, we are combining because both are hard, so we are going to combine their rates. Now let n be the number of days for combined work. So suppose John and Joseph will take n days. We do not know what is n, but we just of course it will take it's going to be some positive integer or real number. Suppose they can take n days where n is unknown. Then the combined rate for John and Joseph will be, so John and Joseph, the rate of work will be 1 divided by n because they can take n days to complete the whole task. So in 1 day, they only do an n.
We can see there. Excuse me, we can see what is written at the, after Joseph. After Joseph, I can see the, oh, thank you.
Okay. So John and Joseph can complete the work in 1 over n. The rate for John is 1 over 7. The rate for Joseph is a quarter. The combined rate is 1 over n. So the equation here is that 1 over 7 plus 1 over 4 must be 1 divided by n. Okay. We're looking for this n because we're interested in this. We know this will be the combined rate. The rate for John is a 7, for Joseph is a quarter. So the combined rate, you just add these two fractions that we have done here. And then if they will take n days, then the combined rate should be 1 divided by n, which is what we have here. So this is a fraction. What is the LCM of 7 and 4? LCM of 7 and 4?
28.
28. So what do we have there? 4 plus 7 must be equal to 1 over n. This means that 11 divided by 28 must be equal to 1 divided by n. So what is n from this?
Did you like cross multiply or something?
N will be 28 divided by 11. Yeah, just invert both sides. Huh? And this should give you, let's see, 2 point. So this is 6. So that should be 5. And then you get a 4. So 0.3. And then you get
54545.
2.54. 2.55. 55 because it's a recurring number.
2.55, huh?
Yeah.
So we are getting that combined, John and Joseph will take, so let's round off to the nearest 1 decimal place, 2.6. Huh? So approximately 2.6. They will take approximately 2.6 days. Our question was, can they complete the work in 2 days? So the answer will be no, because they will take more than 2 days. Okay, it is 2 days and some hours, so that is not in time. So this work cannot be done in 2 days. If this work was so urgent, then you need to bring in the effort of a third person so that this can go down to less than 2 days.
Also, I have a question.
Yes.
I'm trying to understand why you put actually 1/n instead of just putting just n. What is the explanation behind like the 1/n there?
Where I put?
You said let n be the number of days for combined work.
Yes.
And you combine the work of John and Joseph, you put 1/n. Why did you put 1/n instead of just putting n?
Yes, that's a good question. First, I started by saying that n is the number of days that John and Joseph working together can complete this piece of task. N is the number of days. So the rate will be the whole amount of work divided by the number of days you can take. Just like the guy doing 7 days can take 1 divided by 7. So the whole piece of work divided by the number of days, which is 7. Similar to Joseph, who takes 4. So we take the whole piece of work divided by 4. Now combined, they can take n days. I don't know what n is. So the combined rate will just be the whole piece of work divided by the number of days they take, which is n. That's why I put here 1/n, where n is the number of days of the work. Remember, I'm using rates. I'm using the rates, not the number of days, but I get the rate from the number of days that they can take to complete the whole task. So I'm taking the whole task to be a 1.
Oh, okay. So this is the rate for 1 day for John and Joseph, if I understand well, right?
If you
or
do,
not?
Come again, please.
I said the 1/n is the rate for John and Joseph for 1 day, if I understand it well.
Yes. So 1/n is the combined rate. So every single day, John and Joseph combined will be completing 1/n of the task. That is the meaning of this. In 1 day, they will complete 1/n of the complete task. In 1 day, John will complete a 7th, John alone. In 1 day, Joseph will complete a 1/4. But combined, if you're taking n days, they will take 1/n and n. So that's why I combine these daily rates, because this is the rate, this is the amount of work John does per day, the amount of work he does per day. So I combine the two. This must be equal to the combined rate for them. And then from there, I get my n, which is 2.6 days. It's way about 2 days.
I have a question.
Go ahead.
Yeah, so when we got 11/28,
yes,
that was the combined, like in 1 day, they can both do 11/28.
Yes.
At all, right?
Yes.
So, and the question was, is it possible to complete the work in 2 days? So what if I said in 1 day, they can work 11/28? What about 2 days? So I'll get 11/14 and just say, then they cannot complete the work in 2 days instead of getting the value of n. Is it the same? Or will it be correct?
Let me see. You're saying in 1 day they can do?
In 1 day, they can complete 11/28. Yeah, that is in 1 day. That is the amount of work, right?
That's in 1 day.
What about, the question is it possible to complete it in 2 days? So we need to see what amount of work they can work in 2 days.
22 divided by 28. And this is.
So is it okay to say that? I can just state my answer as they cannot complete it in 2 days. Because are we supposed to find n, or are we supposed to answer that they cannot complete it in 2 days?
You are supposed to answer that they can complete or they cannot complete. So when you get 11/4, remember this is a fraction. So if they are getting a 1, right?
Yeah.
Yes. So because this is a fraction, the answer is no. So that approach will still carry.
Excuse me, sir. Isn't it
it will
supposed to be
still
like
get
14 out of 11 instead of 11 out of 14?
No. The rate, so each day they complete 11.
Yeah, yeah, I understand. Like,
One day they
because
complete 11 over 28. So in
Yeah.
days, you just take the 11 over 28 plus 11 over
Plus 11 over 28.
You get
11 over 14. So if I worked out using that method and got 11 over 14 and then said they cannot complete the work in 2 days, would I
Yes,
be
that's okay.
right?
That's okay.
Oh, okay.
That's okay. That's
Thank
very
you.
much okay.
I have another question, sir.
Go ahead.
When we say let n be the number of days for the combined work, it means n is the same as 1 over 7 plus 1 over 4, meaning 1 over n is 1 day of combined work. 1 over n is 1 day of the amount of work they can do in 1 day.
Yeah, you're right. So 1 over n is the rate of combined work for both of them.
Okay.
Yes.
Thanks.
Sorry, sir.
Mhm.
Isn't it 1 over n the amount of work they can do in n days, in days that we don't know, that we're looking for?
1 over n, so let me make this clear. 1 over n is the amount of work they can do in 1 day if they are taking n days.
What? Okay.
If John can take, so John takes 7 days to complete the whole work. Huh? So suppose this is the work that John is supposed to do. Then the rate will simply be the whole amount of work divided by the time it takes. So this is the whole piece of work. So first day, second day, third day, fourth, fifth, sixth, seventh. So first day, John will complete 1 over 7. Second day, 1 over 7. Third day, 1 over 7. Fourth day, 1 over 7. Fifth day, 1 over 7. Sixth day, and lastly, 7th day. So that if you add up all the amount of work that John does in the 7 days, you should get the whole work complete. So if I'm only interested in 2 days, then in 2 days, John will do 1 over 7 plus 1 over 7, which is 2 over 7. Suppose they are taking n days where we do not know n, then you have, you've got the whole piece of work. And on the first day, they do 1 over n. Second day, they do 1 over n. Third day, 1 over n. All the way to the nth day, 1 over n. So that after n days, the amount of work done is 1 over n plus 1 over n, all of this added n times, so n over n, which is 1. That is why if you're asked if they are able to complete the work in 2 days, then just take the rest a day, multiply it by 2, add it to itself. If that gives you a 1, then it means the whole work will be complete in 2 days. If you get a fraction as we are getting 11 out of 14, then it means the work is not possible to be accomplished in 2 days.
I have a question. When you were saying the 2 days for John, 1 over 7 plus 1 over 7, why did you say 2 over 7?
Why didn't I say 2 over 7?
Yeah.
Yeah, I can still do the same. I can take 2 over 7, that is John, combined with Joseph will be 2 over 4. Okay? Then my answer will be yes, they can if this gives me a 1. If this gives me a fraction, the answer will still be no. So let us add this. LCM is 28. 7, 4. 4 times 2 is 8 plus 4, 7. 7 times 2, that's 14. 8 plus 14 is 22 divided by 28. So when I combined the rate, the amount of work done in the first 2 days, I get 22 over 28, which is a fraction. So that basically means they are not able to complete the piece of work in these 2 days because there is still.
Excuse me, Mr. Professor. Isn't it supposed to be 28 out of 22? Because at the end of it all, you still have to like invert the fraction, like 28. The denominator goes on top, then denominator comes down. Because you can't just stop there at 22 over 28. You can't divide that.
Please do not mix the number of days with the rate. These are two different. The rate is simply, let me give you the definition. Rate is simply, for this, in this particular context, is the amount of work divided by the number of days. I just want to see each day how much, each day, how much piece of my work is getting done, okay? Rate is any quantity divided by time. It could be in seconds, it could be in hours, it could be in years, it could be in centuries, light years. But for this case, if the amount of work, let's say you have a piece of work to be done, then you give it a 1. The whole amount of work is 1. So the rate will be this 1 divided by the number of days that someone takes to complete the whole task. So if someone takes, let's say, 10 days to complete this piece of work, then their rate of work is simply the work per day, which is 1 divided by 10. So in the first day, they will do 1 over 10, second day, 1 over 10, all the way to the 10th day. So that after 10 days, it is 1 over 10 times 10, 1, which means the whole work is accomplished in 10 days. And of course, here we are taking, this is ideal. We are not taking consideration that there might be some interference. So maybe on a day you are sick or you are a bit tired, so you do not work as hard as you did on the first day. This is ideal. We are assuming that there are no any other factors that affect this, the rate at which this people work. Okay, sickness, maybe someone gets to work, they're not very happy, they're not motivated, so they don't work as hard as they did the last time. We are considering the ideal situation. All other factors are constant. Definition of rate is simply the amount of something, in this case, the amount of work divided by the number of days. If it was flow of water, it will be in liters per, maybe per second or per hour or per day. Suppose there's a tank which is leaking. It's leaking maybe per second. You could calculate the rate of the leakage in terms of liters per second or milliliters per day or deciliters per hour.
So,
Professor, hold up, like it is my point. On the division, like after adding up the number of days, like the 1 over 7 or the 1 over 10 plus the other one, you end up getting a fraction like 11 out of 28, right? So now the big number can't be the denominator because you have to divide to find the number of days, like the way you've done it there. Find
You're right. If I want to find the number of days, then I have to invert.
So it literally goes back, like number of days will go on top. And
if I want to find the number of days, then I have to invert the rate. So I have to take, in that case, 28 divided by 22.
11.
Yes.
Yeah. All right.
sorry, sir. So I just have a question for, I think the whole logic that you use was to assume that the amount of work was 1, not to assume, but to represent it by 1, right?
Exactly.
So we could also just logically say the amount of work is, let's say, X. We don't know what is that. And then after the whole thing, it will cancel out.
Exactly. That will still work. That will still work because you will have it on both sides of the expression and you can cancel it out.
So,
yes.
If you ask such a question in an exam, would you want to see which working out we use to arrive at, you know, true or false, or do you just want to see like true or false without the working out?
I will specify, like in the quiz, I specify that the first 4 questions, the first 8 questions are true or false. The second part you specify. So if I ask you whether it is true or false, but then I'm expecting you to do some working, then you have to do the working before you conclude whether it's true or false. If it's just a true or false question, then you work it out. If it's true, you say it's true. If it's false, you say it's false. So that will depend on the instructions.
Okay, thank you.
Okay, I think we are done for today. We meet next week. Any more questions?
I just wanted to know if it is possible to give us like more exercise on that, so we can just
there is
practice.
On this. Are you able to access the college text from the Blackboard? The course text from the Blackboard?
Course text, yes.
Course content.
No, course text. I'm very specific. Course text.
Yeah, I think we can figure it out.
Yes, you can find more examples from the course text, and I will also send you another book by Stewart where you can also get more exercise on this.
Are there answers there?
The answers?
Yes.
I don't think, but you can always, as others have been doing, you can do your work and then you send it to me for checking.
Okay.